So we're looking at collections this week, and some of this is going to be a little bit of old hat from what we've looked at in previous weeks. We've talked about lists, we've talked about array list, linked list. I've introduced you, in fact, to using some components like the HashMap and the TreeMap. But let's dig into it a little bit deeper today. So let's start with the enhanced for loop. We've already actually introduced this enhanced for loop to you, haven't we? Yeah. It's also called a for each loop, depending on who you talk to. So the idea behind it with the enhanced for loop is you're declaring a new variable of the type that the collection contains. So it's all around the idea of generics, right? So whatever that list object contains, it could be a custom class, it could be an integer, it could be a string, it could be anything that's an object, right? It cannot contain primitives though, okay? Only objects. Okay, and with an enhanced for loop, you move forward. You cannot go backward with an enhanced for loop. Okay, the other thing about with enhanced for loop is you can't write to the loop. Okay, you can't write with it. It's only for reading. All right. So, classic example. You'll notice here that we are declaring a new variable that will be assigned with each successive element of the contained object. So every time it iterates, it is creating a new variable on the fly called name, and it's assigning whatever is at the next iteration to that value, and then we're just printing it out. Okay? Any questions so far with what the enhanced for loop is doing? Okay? All right, so enhanced for loop really gives us it's improved code readability. Think about it like this. This was the old way of writing a for loop. And by the way, this is not necessarily the wrong way. Okay? There are times that you're still going to need to access some item within the collection and you need to change it. And if that's the case, then you're going to need to use a for I equals 0, blah, 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 right? But as far as readability, this is very easy to use. It's very easy, okay? So when we're thinking about the enhanced for loop, we're usually using something like some type of collection. And the most basic of collections is a list container. Now we've already talked about the array list, and Java provides in their collections framework a number of different types of ordering elements that you can use. Many of these are like linked list, the array list, there's a bunch. There's hash maps, there's sets, there's queues, there's Deques, all kinds of things, stacks. So as you can see here, can someone tell me what the T represents?
Either string or integer.
Yep, string, integer, any object, right? As long as it's an object. What I want to go ahead and show you here, this is the Java doc for the list. Whoops. Let's go back to that. We'll open it up. And let's see, is there a... There we go. Make it a little bit easier for everyone to read. So you can see that the list exists in Java util, right? And it takes an element, and this is whatever that element could be. Now, it has the list interface extends from collection and also from iterable. These are important to remember because there is a iterable collection that you can use with a list, and we'll talk about that more. These are known classes that implement the list. Abstract list, abstract sequential list, array list, attribute list, copy on array, write list, right? There's a bunch of these. All of these implement the list. And of course, you have all of the finer detail about what the list is. I recommend that you take time to look at the Java doc. You'll find this at docs.oracle.com. This is version 11, but the list has not changed. It's pretty much the same as far as the documentation goes, all the way up to 17. All right. So that is the list. Now, does anyone remember the discussion about the linked list? How you would create a linked list with nodes and all of that? Well, Java Collections has an abstract data type. Anytime you see the term here, ADT, this is abstract data type for the linked list. And the way you declare a linked list is pretty much just like what you see here. Linked list, the type inside of the greater than, less than symbol equals new linked list. And T represents the type, so integer, string, any object you want to apply to this. And of course, you import it using the Java util linked list. Okay? You guys remember that slide? That's what's going on behind the scenes, even in the Java collections. This is the linked list. But they've done it for you, so it makes it a whole lot easier to use their collection. Does anyone remember the linked list? Is it single link or double link? Yeah, it's double, because with Java's collection of the linked list, you can go both forward and backwards in the collection. And that's important because the linked list implements the interface list. So if you implement that list, that means that that collection object has to provide functionality for all of that. Okay? All right, so some common methods for it. We have get, which is you can get the item at that specific index. You can set an item at a particular index. You can add an item, which when you add an item, it adds it to the end of the collection. You can return the size, and you can remove. Okay? Iterating through the list. There's many different ways you can iterate through it. One of the ways to do that is inside of a for each or a enhanced for loop. The other way is to use a list iterator. Okay? And the list iterator has a couple of different methods as well. You have next, next index, previous, and previous index, as well as has next, has previous. You can add an object with the list iterator. You can set and you can remove. Okay. All of this is actually documented in the Java doc. All right, let's go ahead and create a quick example doing this. Go ahead into your source. We'll create a new Java class, and we'll call this our linked list example. Public static void main method, PSVM, hit tab. We'll do that. Inside of this, we're going to create a linked list. So we'll just say linked list, whoops, linked list. There we go. And this is going to take a type of string. We'll just call this names equals new linked list. I want to point something out here. You'll notice that in a lot of these, we only have to provide the type for the collection in the first greater than, less than symbol. You can do it here as well. There's nothing wrong with it. Okay, you can put them in both places. If you use the new var, you need to apply it at the end. You guys have not even been introduced to this new variable type. This is a variable type that allows you to shorthand create the object. Okay? So if you're going to use the var, you need to apply the generic type to the end of it. The nice thing about using var is it simplifies writing the code. You don't have to write as much. Okay. All right, but for now, let's go ahead and stick with strongly typing and specifying what the object is. So in our linked list, we'll say names. We're going to add a name. Someone shout out a name for me. Evan? Okay. Give me another name.
Ryan.
Ryan. Okay, another name. Keep them coming.
Ezra.
Damn.
Ezra. Did someone say the next name is Dan? No? Okay.
Add my name, Francisco. Now that we're even.
All right. Francisco. Every time I hear the name, I think of the movie Elf. You know that scene in Elf where he's standing there and he's sitting on his little chair in the corner reading his book and he's going, Francisco. Francisco. Does anyone remember this scene? And his dad says, you want some coffee? And he's like, drinking the coffee. Anyways, all right. I'm sorry, I'm off on a random tangent. All right, so it's basic just exactly as a list. And in fact, we could change this implementation and start it with the interface. And you notice that add is the method that's used by the list, right? So if we click on it, we'll drill down into this. We can see that add, you can add it, and if it works, it's going to return a true. If it doesn't work, it returns a false, right? But this is for the list interface. And so linked list, if we go ahead and drill into it, we can see that linked list extends abstract sequential list and implements list, as well as Deque, clonable, and several other things. Not Deque, Deque. Let me say it correctly. All right. Any questions so far with what we've done? Do you guys understand why this is possible? Yes? No? Yeah?
No.
Who doesn't understand why it's possible? Okay. So linked list implements a list. You remember our session we did where we created a person and then we extended from that and created a student. And we also extended from person and we created a teacher, and right?
Similar to that.
Exactly. Yeah. Here, the list has abstract items that have to be implemented, and they're implemented by linked list. The one thing I want you to catch, though, is because we're using the interface list, I'm limited now to only the methods that are available at the list interface. I can't use any of the methods that are available over here for the linked list. For example, if I go down and I try to use some of these, well, public one anyways, link before, it's not available because that's in the class name. So it's like you picking up a filter and putting it over your remote, and you can only press the buttons that the filter has, right? That's what the interface does. The interface is nothing more than just a specification that says these are the only things that are available. And as long as whatever's underneath it supports it, it'll work, right? Okay. So we've added those items. Let's go ahead and take this back up and use a linked list because we want to show an example of using the iterator. So we're going to say names, and here's our iterator. Okay? So do that. And we'll introduce the variable. So now we have this object called an iterator. And over here, this was a list iterator is what it was available before, right? So let's take a look and see what is available here. Last index. Yeah. We haven't talked about streams yet. Streams are a really cool technology, but that's not something you would cover at this level in Java. I think that covers it. Okay, so we have the iterator. Let's talk about how you use that iterator. Okay. Let's first of all just check something. List iterator. Let's see if it'll allow us to. That was weird. And I don't think it's going to let us cast that. Yeah. All right, so we have our iterator. The way the iterator works, it allows us to kind of loop through the methods. So we can just say for iterator let's see, while, there we go, iterator has next. System out print line, iterator, next. Iterators are really what is used under the scenes when it comes to the enhanced for loop. So when you call the enhanced for loop and you use it on a collection, under the scenes the iterator is used. So what we're doing here is we're actually gathering the iterator and we're using it directly. Okay? So if we run this code, you can see it just automatically prints out the names. The has next is basically a method that says, hey, before I call next, is there a next? If it's true, then run the loop. And so then we call next, which increments inside the iterator, and this then method then asks the question, well, is there something next after it? And it just keeps the loop going. All right, any questions so far? All right, let's go back to our examples here. So the next type of collection we have is called a map. Maps are a little bit different than what you may have been thinking about. It's not like what you'd put on the wall. A map is, at its basic level, it's an associative array. It's two items that are associated together that allow you to access the value. So you guys took SQL class, right? Database class. In your database class, you use things like select from table where the name equaled something, right? Essentially, a map is allowing you to create, a map is like that same type of methodology. You have a key that you assign at the entry point, and then you have the value that is associated with the key. Hence the term associative array. You have a key that's associated to a value. So in this example here at the bottom, you can see that we have a key and a value. And again, K and V are generic, which they could be anything. string, integer, right? Object. So let's take a look at a common example here. We have HashMap, K and V. Again, K and V is just emblematic. It's metaphor for key and value. Okay. What this could actually be a string, and string is usually the most common version of this. When you're creating a hash map, the key must be unique. Okay, must be unique. You can't have duplicate keys. They have to be unique. And that makes sense because when you call it, you're going to call it by the key. So I use my key and I say, give me what's associated to this key. And it gives you just that object. Okay? All right, let's do an example here. Let's go ahead and maximize, well, create another class. And we'll call this our map example. Okay. Again, create a public static void main method. Inside of it, we're going to use the interface for the map. So we're going to say map, and we're going to assign what the key value pair is. So I'm going to say that my key is going to be a string type, and the value is going to be an integer. Okay? Again, the value could be anything. It could be any type of object. So say, for example, you create a person object or a car object or whatever. You could always store any of those types in the value parameter. So we're going to say map string integer, and I'm going to say this is going to be salary equals a new, and I have to, at this point, because map is the interface, I have to use an implementation that already exists. So I'm just going to use a common one, and that's the HashMap. So we're going to type salary put. You'll notice that is a different keyword than add. There is no add in a map. There's only a put. Okay? So I'm going to start again, and I'm going to basically come over here and copy some values to make this easier for me. And let's just do this. And I'll say put. And we're going to fill out the rest of these in a second. I just want to quickly get some data up here. All right. How much is Evan going to make? What's his salary going to be? What's that? 50,000. All right. And Ryan?
One.
Just one?
Yeah.
Oh, man. You can't even buy bento for $1. Ezra's going to have 100,000. All right, Francisco. What is Francisco going to make?
73,000.
73,000. Okay. So you can see here in the example the way this works. You have the key, and then you have the value, right? Key, value, key, value, key, value. Now I want you to watch what happens here if we try to add another one using the same key. Let's say that we're sad that Ryan only got $1. And so we say we actually meant that. Now, the way this works is that when we put the item in, you may think, well, Mr. Rogers, why isn't it, it should throw an error, right? Well, that's not the way this works. When I put something in with the same key name, I'm overriding what was at that indice. What was at that value, that key range, okay? And so this kind of gives you some flexibility then, because, you know, like, well, that's sad. He only got $1. That must have been a mistake. And so then we add later another put to update, right? To update the amount. Now, if we're going to print these, there's a number of ways we could print it. We could try to do salary get, and I want to see the salary for Ryan. So I'm going to surround this in a system out print line just so we could see it. And if we run this, we can see it prints the salary for Ryan. It does not print this one because this is overridden. You guys understand? Okay. The other way that we can actually access the values inside of a hash map is you can use what's called a key set. So you would grab the key set, and the key set is going to give you which is something we're going to get into in a moment, but it's actually going to give you a set of values, a set of keys. So we're going to generate a key set, and we'll go ahead and let it introduce the value. And we have this new type of value called a set. Now we're going to talk about a set in a moment, but basically a set is a collection of values that cannot be duplicated. You cannot have duplicates in the set. And that kind of makes sense, right? Do you guys have collections of things at home, like collectibles? And you try not to have duplicates, right? You feel bad when you go to McDonald's and you ask for your Happy Meal and you get the same stinking toy again, right? I'm touching a raw nerve now, aren't I? All right. So a set is unique. It's a distinct collection of items, okay? So when we get the set, and that makes sense, right? Because we can only put in unique keys. We put in another key of the same name, we overwrite the original key, that value. So when we get the set, what we do is we can basically, now we have a collection, and we can take the set of, let's call this salary keys, so it makes more sense, okay? So we're going to have our set of salary keys, and there's a number of methods available for this, but that we could use. We could also get another iterator if we wanted to, or we could just do the easy thing and say for string salary key colon salary keys, right? And we could simply print out those salary keys if we wanted to. And printing it out, well, you know, what is that going to give you? It's going to give you the list of names. But let's say I want to print out not just the list of names, but I want to print out the actual salary. Well, the way you do this then, let's add another system out print line, and let's take the salary, and we're going to say get, and pass in the salary key. Are you guys following me what just happened there? Up here, I use the get method because I know the key. Down here, I'm iterating through the set of keys, and I'm passing it back into the get. And when you run that, you're going to see that you now actually get the name of the person, which is what we have here, the salary key, and we're getting from the hash map by passing in the key to get the value. Okay? All right. Any questions so far with what we've done? Hash maps are really a cool way of handling things. But there's also some other implementations of the hash map which I think are really cool. So for example, we could change our implementation here. Excuse me, there's other implementations of the map that are really cool. And one of them is using the tree map. So with a tree map, you get this way to automatically sort the values. And just because I've done this as tree map now, you're going to notice that these names, when I print them, are going to come out in a different order. Now, we're going to take out this one here just for a second, and I'm going to move Ryan up to there, because I want you to see that this will automatically sort using the tree map. So I've used the tree map. I'm going to drag this up a little bit, run it again, and now you can see that it sorted it in alphabetical order. Evan, Ezra, Francisco, and Ryan. Even though I put it in one way, the tree map automatically alphabetically sorts it. Okay. There are some trade-offs when you're using a tree map. The HashMap is super fast, okay? Because everything that you put in a HashMap, it's going to give it right back very quickly, okay? If you iterate through it. Tree maps are a little bit slower. Let me go down to this. Tree maps, they're slower because they maintain a proper order for using them, okay? All right, let's go back here a little bit and look at the HashMap methods that are available. So we can put if absent. That's kind of a cool method, right? What that means is it's going to actually check if the key is there, and if it isn't, it's going to put that key in value. Otherwise, it would not. We have the get method. We have a method called contains key. That can be powerful, right? Say you have a huge collection, a huge hash map, and you're like, well, does this hash map have this particular key in it? Well, you can check it right away, okay? Contains key. You also have contains value, so you can actually search on the other side of it. I can check for the key, but I can also check for the value. And this may return one or more. Okay, you have to be careful there because it could return. Well, it's going to return the first is what it'll do. The first value that it finds. You can remove a key, which is I've used that 100 times in writing code actually, and I can actually clear the whole collection with that statement. You can grab the key set, or you can grab the values. And values is, again, it's a set of values. Key set is a set of the keys. All right, any questions so far? All right, let's go on. So we're now back to the set. So you may be thinking to yourself, this is kind of strange. Why would I want to use a linked list when I could just use an array list? Or why would I want to use a hash map versus a tree map? Or why would I want to even have this thing called a set? It's because each of these APIs do specific things, and they're optimized in memory for their particular task. Okay? My dad used to tell me when I was outside working, he says, if every task looks like a nail, then every tool is what? Yeah. But obviously, going out to try to mow the lawn with a hammer is not very, it's like I'd be out there all day. But that's what happens a lot of times when we're programming. We think array list, array list, array list, array list, array list, array list. And we get into a lot of memory issues when we could use the proper API, the proper framework, proper collection, like a linked list. Or we're like, well, I only want a distinct set of values, but I'm going to use an array list. And then we get mad because the array list actually has duplicates when we could have stopped the problem with just using the proper collection type, the set. So you got to think about which type of collection you're using. All right, so we've talked about the set, and we if we go back and look at the code example here, you'll notice that when I say salary key set, what does it give me? It gives me the interface. Because salary key set, if we were to actually drill into this and look at it, well, that's hard to read, isn't it? Let's see. It returns a set of values of keys in the map. Set is backed by the map and changes. I'm trying to see if I can find it here. Usually, I'm not sure. I think this is actually, the key set is actually under the covers, supported by a HashSet. Okay. All right. So let's go back to our logic here. So set is the interface, and the one we typically use is the HashSet. HashSet is the implementation. Okay. All right. Any questions so far with the set and the HashSet? All right. Today is all about collections. This whole week is nothing but collections. It's not a hard week, though. It's a very easy week. Okay. All right. So you have some various methods with the set. You can use the add, and the add method will fail and return false if it's duplicate. So we'll look at that example in a second. You have add, you have remove, you have contains, and you have size. And by the way, size is, I think all of these first set of methods here are the same ones that are for a list. So let's check something here. Let's go back to our code. Let's click on set. Set extends collections. Collections extends iterable. And if we look at it, contains, add, right, remove. That's because let's go over here to the linked list and look at the list. That's because list extends collections. So when you're looking at the hash set, what you're seeing here with these methods, they share a common ancestor, the collections interface, right? Okay. All right, so we have HashSet and TreeSet. HashSet is an ADT. What is an ADT again? It's an abstract data type. Some of you were like running through the list of words in your head, weren't you? Abstract, doofus, type. I don't know. All right, so HashSet, TreeSet, they're abstract data types. They implement the set interface. Okay. Keep in mind that the HashSet is always going to be faster than the TreeSet. And why is that? Why do you think? It's on the slide, so maybe you guys could tell me. It's the same reason for the HashMap and the TreeMap, by the way. Because the TreeMap is ordering, it's slower. TreeSet is ordering, it's slower. Okay? All right. Okay, now we're getting to the next one, the queue interface. Let's just talk about for a moment what a queue is. What comes to your mind when you hear the word queue? What's that? And where do you usually get into a line at? The drive-through, not the grocery. I always thought about standing in line at the grocery store. All right, so let's say you're at CupBap, right? There's no real way at CupBap that you can actually drive up and get in front of someone, is there? The way that drive-through is implemented, you can't do it. If you did, you'd probably ruin your car. All right, but think about queues then. So what happens? What's the methodology behind a queue? Always added to the end, right? What is the rule? We have a fancy acronym that we use for describing queues? FIFO.
First in, first out.
Oh, you guys know that one.
Accounting.
Yeah, first in, first out. So whatever, the order of the queue is super important, okay? Order of the queue. Now, think about where you might use queue logic at then in coding. Where might you use a queue logic at? Maybe the McDonald's drive-through, right? It'd be pretty important for whoever's working at the counter to make sure that they have the order established, right? That the order's coming in. So in your code, you would want to use a queue, right? Queues are important, right? Because you could technically have duplicate of the same order, right? And I'm probably sure Monday mornings at 8 o'clock, 7 o'clock, whatever, everyone's ordering the same thing. Sausage, egg, McMuffin with an orange juice. And they want to make sure, but this guy wants ketchup with it. He's weirdo. He wants ketchup with his sausage, egg, McMuffin. Right? The order of the orders are pretty important. All right. All right. So how do we use queues? Well, the common way to do this is with the linked list, believe it or not. And linked list makes great sense for implementation of a queue because the linked list is optimized for memory, right? But if we go back and look at our code, let's go back to the linked list example and go ahead and drill into that. If we scroll to the top, well, not that far to the top, right? We can see linked list extends abstract sequential list. It extends list, queue, clonable, right? Let's go into sequential list. It extends abstract list, which extends abstract collections, implements list. Somewhere down here is going to be the one we're looking for because it has to. I'm way down in the weeds now. Let me close some of these out. Let's do it again. Linked list. Is it under the list? It's collections, iterable. Somewhere in here it extends. This is driving me batty now. Somewhere in here it implements. Maybe it's under queue. There it is. So you have Deque and you have queue. And you can see that linked list actually, it implements Deque, which extends from queue. So that means that when we're doing our linked list that we could technically do something like this. We could say queue. Now, this won't work anymore. And there we go. Let me do that again. There we go. Yeah. So we have the queue, and we can add things to the queue because what's implementing it is the linked list. So we can use the logic that's already available there. So what other methods are available to the queue? Well, we have add, remove, offer, peek, right? We can remove a particular object. We can grab the element. We can poll, and so forth. We can ask questions if it contains. We can get streams and all of that. All right. Some of that's too far down in the weeds because we're actually using other interfaces at this point. So when you're adding, let's go back to our slideshow here. So when you're adding with the queue, when you add to it, it's just like the McDonald's drive-in or cup map. We're adding it to the tail, and when we remove, it's removing the element from the front of the queue. All right? But here's the other thing. When you're reading from a queue, when you're reading from the queue, I know it's in here somewhere. There it is, poll. Returns the element at the head of the queue, and if the queue is not empty, otherwise returns null. So notice what happens. It removes and returns. So if we go back to our code, and we do names dot poll, not peak, poll, system out print line, and then I do a system out print line names dot size. What we're going to find is that after I read this, the size of the collection will go down. Okay, so we'll run it. We see it gives me the first item in the queue. It reads it, it takes it off, and then when I ask for the size, it says, well, there's only 3. Because the next item in the queue would be Ryan, and so forth. Okay? Now you can also use peek, and peek looks at the first item without removing it. And so if I use peek, then the size of the queue will be 4. So we'll run it again. We can see it's still Evan, but now the size is 4. All right. Logically, the way this works is queues are very powerful if you're trying to create some type of a state machine. And there are a lot of actual servers that are designed around the idea of a queue. In fact, I've used several in my job. One's called ActiveMQ, one's called RabbitMQ, and basically you have a bunch of messages that come in, and they populate them to the queue, and they set there on a separate server. And then when this other process reads from the queue, it does exactly what you would expect. It grabs the first element, it takes it off the queue, and it processes it and does what it needs to do. So that's kind of the idea behind it. All right. You guys look very tired right now, so let's all stand up for a moment. Stretch your legs. You guys okay? All right. I know collections can seem a little boring, but this is important stuff as far as this class goes, okay? All right. Any questions about the queue? Any questions? All right. Let's go back to our slide deck one more time. All right, so we have poll, we have element, peak, all of those. All right, so common queue implementations. We have the linked list. There's also the priority queue that you can use. There's the linked blocking queue and the array blocking queue. Now you can tell right away that the linked blocking queue is probably related to linked list and their functionality. An array blocking queue is related to the similarly the array list. There are apparently other type of implementations for the queue that you could use. I recommend, if you want to learn more about the different ones you want to use, remember, not every problem is a nail, so it means that not every tool is a hammer, right? If you want to learn about the different ways you could use these, look it up in the Java doc on the Oracle website. All right, and we're to our last collection of the day, of the week, in fact. And if we're to be honest, for this class, for the year. Woohoo! Some of you are like, Mr. Rogers, you're being too dramatic. All right, so I'll be honest. When I first read this, I always called it a DQ.
I know like
Deque. And the reason I called it a DQ is because this was a Q. And so you put a DE in front of it, it must be a DQ, right? It's actually pronounced deck. Okay, deck. And a deck is like a deck of cards or a stack. So the interface here basically gives you an ordered set of elements that support insertion either at the beginning or the removal. And you see my little statement at the end there, okay? It can take insertion from the beginning or the end of the queue, of the deck, excuse me. So that's important to know because when you think about what you can do with a deck, it kind of reminds you of like a set of cards, right? It's a special implementation, and it makes sense then why you could use a linked list for a deck, because a linked list stores its memory in all of these locations, and it doesn't matter then where you grab the element from or where you insert it, because it's super fast, right? Okay. The main methods that are commonly used this are add first and remove first, as well as add last and remove last. And again, the deck is a stack. It's an abstract data type, either added or removed from the top of the stack. So you have add first, adds an element to the head of the stack. You can add first, shifting elements in the deck to make room for new elements. You can remove first. You could add first actually with the new element. You could add last. You could remove first. You could remove last. Same ideas. You could poll, which removes the element, reads it and removes it. Or you could get first. You could get last, so on and so forth. Okay? All of the same types of methods that are available to a queue are also available to a deck, but it gives you the ability to more flexibility. Okay. Guys, that's it, I believe. Oh, there we go. Common implementations. Linked list, array deck, linked blocking deck, concurrent linked deck. Okay? And that's it for the day. We are done. So if you have any questions with your assignments or you need further assistance, I'll be here for the next 15-20 minutes. Otherwise, I will see you all next week when we start looking at GUIs. And again, please be reminded that you need to go back and look at all of those assignments, okay? Yes?